We have f of x is x plus 2, x squared plus 4. We want to show the graph has no stationary points. So if we differentiate, this is a product with u equal to x plus 2 and v equal to x squared plus 4. So du dx is equal to 1 and dv dx is equal to 2x. So dy dx would be equal to v du dx plus u dv dx. So that's going to be x squared plus 4 plus 2x x plus 2. So that's x squared plus 4 plus 2x squared plus 4x, which is 3x squared plus 4x plus 4. Now, for stationary points, dy dx is equal to 0, which means that 3x squared plus 4x plus 4 is equal to 0. Now the thing is to show that this has no real solutions. You can either use your CAS to do that, or another way of doing it is to use the discriminant. b squared minus 4ac would be, so b is 4, so that's 16, take away 4 times a times c is 4 as well. So that's 16, take away 16 times 3, so 48, which is negative 32. And that implies no real roots. So there are no values for which dy dx can be equal to 0. I should note back in part A here that this was given as f of x, so of course f dashed x could well have been used for the derivative. Anyway, let's go over to here. Find the values of x for which the graph is concave down and the values of x for which it's concave up. Now that's to do with the second derivative. So since I've gone with a y notation, I'm going to go d2y dx squared. I probably should have defined let y equals, but it doesn't matter that much. So that's just going to be 6x plus 4. So let's put 6x plus 4 equal to 0. So 6x equals negative 4. X is going to be negative 4 over 6, which is negative 2/3. Now, if x is less than negative 2/3, say negative 3 or something, this is clearly going to be negative. So d2y dx squared would be less than 0. And we know that that means it's this shape, so that's concave down. When x is more than negative 2/3, just try something like 0, d2y dx squared is positive, which means we have this type of shape here. So that is going to be concave up. Sketch the graph of y equals f of x, indicating the values of the intercepts. So here's some axes, so x and y. Looking at the original, there's no value of x that will make this 0, but x is negative 2 will make that 0. So that's one intercept. And if x is equal to 0, This just ends up being 2 multiplied by 4, so that gives us 8. Now we know that negative 2/3 is an oblique point of inflection. And we know that prior to that, on this side, the curve is concave down. So that must shape like this. And then afterwards it's concave up. So that means it must shape like this. So let's just mark that point on there at negative 2/3.